All right, here we are for Honors Physics Universal Gravitation Worksheet 3, Problem 2. This problem asks, hey, if the distance between two objects is tripled and the mass of one is doubled, what happens to the size of the gravitational force between them? And so you say, all right, we're going to solve this just like we solved the previous problem using that same technique. We have a situation, we're making a change to a variable or variables, and we want to know how it affects another variable in the equation. And so we're going to start by just jotting down the formula, right? Fg is big G, and 1 m2 over r squared. And the changes we're making this time, they want us to take that distance and triple it. So instead of squaring r, that distance between the middles, we're going to square a number that's 3 times as big. So it can be 3r quantity squared. So like 3 times 3 times r times r. The other change we're making is we're going to double the mass of one of the objects. So we're going to replace one of them with a mass that's twice as big. I don't know, maybe this one gets twice as big. Sure, why not? So we'll multiply that by a 2. Right? Now, the other mass is staying the same, right? G is a constant. It's staying the same. So to keep the two sides of the equation equal, if I make these changes here, I have to make the same changes on the other side. So I'm going to have a 2 on top and a 3 squared on bottom. So there's going to be a 2 on top and a 3 squared on bottom. And you say, hey, that'll be 2/9 what the original force was. And so that's it. That's the answer. My new force is 2/9 as big as the old force. And that's problem 2.